Hello everyone, welcome to my YouTube channel. In this video, we are going to see questions from moment of force and couple. The first question is, the moment of a force is option A, the turning effect produced by a force on the body on which it acts. Option B, equal to the product of force acting on the body and the perpendicular distance of a point and the line of action of force. Option C, equal to twice the area of the triangle whose base is the line representing the force and whose vertex is the point about which the moment is taken. Option D, all of the above. The moment of a force about a point is the turning effect of a force on a body. Moment of a force is the turning effect of a force on a body. And the magnitude of moment is calculated from the equation m is equal to p into L, where p is the magnitude of force and L is the perpendicular distance between the point and the line of action of force. And we can also calculate the moment of a force from the equation twice the area of the triangle whose base is line representing the force and whose vertex is the point about which the moment is taken. Okay, if we consider this figure, if a force P is represented in magnitude and direction by the line AB, and we need to find the moment of this force about point A, the point O, then we can simply calculate the area and multiply it by 2. Then we will get the moment of the force P about point O. So moment of a force about any point is equal to twice the area of the triangle whose base is line representing the force and whose vertex is the point about which the moment is taken. Therefore, the correct answer is option D. The moment of a force is the turning effect produced by a force on the body on which it acts and is equal to the product of force acting on the body and the perpendicular distance of a point and line of action of force. And it is also equal to twice the area of the triangle whose base is the line representing the force and whose vertex is the point about which the moment is taken. Okay, now we can also say moments as either clockwise moment or anti-clockwise moment. Okay, clockwise moments are the moment of force whose effect is to turn or rotate the body about the point in the same direction in which hands of a clock move. If you see this figure, the forces about the points O will rotate. Okay, a line connecting O and the point of application of force in clockwise direction. Okay, therefore we can say that the moments of these forces about point O is clockwise. Similarly, anti-clockwise moment is moment of force whose effect is to turn or rotate the body about the point in the opposite direction in which the hands of clock move. Okay, if we see the forces in this figure, these all will rotate a body connecting point O and the line of action or point of application of this force in anti-clockwise direction. Okay, therefore, the moments of these forces are anti-clockwise moment. Now let us see the next question. A force is acting at a distance L about a point O. The moment of force about A is option A, P into L, option B, P divided by L, option C, P into L into A, option D, P into L divided by 2. We have seen that the moment of a force is equal to the product of the force and the perpendicular distance of the point about which the moment is required and the line of action of the force. This means that M is equal to P into L, where P is the magnitude of force and L is the perpendicular distance between the point about which the moment is required and the line of action of the force. Therefore, the correct answer is option A. A force P is acting at a distance L about a point A. The moment of force about A is P into L. Now the next question is, a force of 20 Newton is applied perpendicular to the edge of a door of 0.9 meter wide. What is moment of the force about the hinge? Option A, 18 Newton meter, option B, 19.1 Newton meter, option C, 22.2 Newton meter, option D, 0.45 Newton meter. We have seen that the magnitude of moment M is equal to P into L. Now in the question, the force applied is 20 Newton and is applied perpendicular to the edge of a door, and it is 0.9 meter wide. Therefore, L is 0.9 meter and P is 20 Newton. Therefore, the moment of this force is equal to 20 Newton into 0.9 meter, which is equal to 18 Newton meter. Therefore, the correct answer is option A. Now, the next question is, the moment of a force about any point is geometrically equal to dash the area of the triangle whose base is the line representing the force and vertex is the point about which the moment is taken. Option A, half. Option B, same. Option C, twice. Option D, none of this. Okay, now if you see this figure, we can represent a force as line AB. Then to find the moment of this force P about a point O, the equation is P into L, but L is OC. OC is the perpendicular direction between the point O and the line of action of this force. So we will get the moment of the force P about O as AB into OC, because AB is the force. Okay, we can represent this force as line AB, and now the area of this triangle OAB is half into AB into OC. Therefore, the moment of this force is equal to twice the area of the triangle ABO. Therefore, we can say that the moment of a force about any point is equal to twice the area of the triangle whose base is line representing the force and whose vertex is the point about which the moment is taken. Therefore, the correct answer is option C. Now, the next question is, Warrington's theorem of moments states that if a number of coplanar forces acting on a particle, then option A, their algebraic sum is 0. Option B, their lines of action are at equal distances. Option C, the algebraic sum of their moments about any point in their plane is 0. Option D, the algebraic sum of their moments about any point is equal to the moment of their resultant force about the same point. Now, if there are a number of coplanar forces acting on a particle, then we can say that the algebraic sum of the moments of all these forces about point O is equal to the moment of the resultant forces about the same point. Okay, this is known as principle of moments or Warrington's theorem. Okay, therefore the correct answer is option D. Warrington's theorem of moments states that if a number of coplanar forces acting simultaneously on a particle, then the algebraic sum of their moments about any point is equal to the moment of their resultant force about the same point. Now the next question is, Warrington's theorem states that option A, algebraic sum of all moments is 0. Option B, algebraic sum of all moments is equal to the moment of the resultant about the origin. Option C, moment of a force is equal to sum of moments of its components. Option D, sum of all moments is equal to its components. We have seen that if there is a number of coplanar forces acting on a particle, then the moment of all these forces about a point O is equal to the moment of the resultant about the same point. Okay, a number of forces can be replaced by a single resultant force. Similarly, a single force can be splitted into number of components. So, Warrington's theorem also states that the moment of a force is equal to the sum of moments of its components. Okay, therefore, the correct answer is option C. Warrington's theorem states that moment of a force is equal to sum of moments of its components. Okay. Now the next question is, a couple consists of option A, two like parallel forces of same magnitude. Option B, two like parallel forces of different magnitudes. Option C, two unlike parallel forces of same magnitude. Option D, two unlike parallel forces of different magnitudes. Now, A pair of two equal and unlike parallel forces, that is, forces equal in magnitude with lines of action parallel to each other and acting in opposite direction, is known as couple. Okay, a couple should have two forces, and these two forces should be equal in magnitude, but the lines of action should be acting separately. Okay, and then the direction of these forces should also be in opposite direction. Then only we can say that there is a couple. Therefore, the correct answer is option C. A couple consists of two unlike parallel forces of same magnitude. Now the next question is, in a couple, the lines of action of forces are option A, parallel, option B, intersecting, option C, not parallel and not intersecting, option D, none of the above. We have seen that the lines of action of forces in a couple should be parallel. Okay, therefore the correct answer is option A. In a couple, the lines of action of the forces are parallel. Now the next question is, the product of either force of couple with the arm of couple is called option A, resultant couple, option B, moment of the forces, option C, resulting couple, option D, moment of the couple. Now the moment of a couple is equal to the product of force, that is one of the forces of the two equal and opposite force and arm of the couple. Okay, if we multiply the magnitude of one of the force with the arm of the couple, we will get the moment of a couple. Therefore the correct answer is option D. The product of either force of couple with the arm of the couple is called moment of the couple. Now mathematically we can say that moment of a couple M is equal to P into A, where P is the magnitude of the force of either of the forces. Okay, then A is the arm of the couple. Arm of the couple is the perpendicular distance between the lines of action of the two equal and opposite parallel forces. Now the next question is, a couple produces option A, rotational motion, option B, translatory motion, option C, inclined motion, option D, combined translatory and rotational motion. Now, a couple is unable to produce any translatory motion. Translatory motion means a motion in straight line. Okay, because if we see, we have two forces which are equal in magnitude and opposite in direction. So the resultant force is 0. But it can produce a motion of rotation in the body on which it acts. Okay, for example, if we apply a couple, to a key to unlock a lock, then it will rotate. Okay, it is an example of couple. So the correct answer is option A. A couple produce rotational motion. The next question is, if the arm of a couple is doubled, its moment will be option A, half, option B, remains the same, option C, doubled, option D, 0. Now we have already seen that the moment of a couple is equal to P into A, where P is the magnitude of either of the forces and A is the arm of the couple. When arm of the couple is doubled, moment of new couple will be equal to P into 2A, because arm of the couple is doubled, and which is equal to 2 into P into A, which means that the moment is doubled. Therefore the correct answer is option C. If the arm of a couple is doubled, its moment will be doubled. Now the next question is, moment of a couple about any point in space is always option A, different, option B, same, option C, none of the above. Let us look at the derivation of the moment of couple. Okay, consider a couple with two forces P1 and P2, which are equal in magnitude and opposite in direction and acting at the lines of action as shown here. Okay, then consider a point O. Then OB and OA are the lines connecting point O and the point of application of these two forces. Okay, then OB dash and OA dash are the perpendicular distances from point O to the lines of action of these two forces. Okay, then take the moment of these forces about O, then we will get the moment of couple. Okay, if we calculate that, first we need to consider the moment of force P1, which will be equal to force P1 into OA dash. Okay, the magnitude of force into the perpendicular distance between the point and the lines of action of force. Okay, and similarly we need to find the moment of this force P2. If we look, force P1 is acting in this direction, so that the moment of force P1 about point O is in clockwise direction. Okay, it is in clockwise direction, so we will consider clockwise moment as positive. But if we look at force P2, the moment about point O will be in the anti-clockwise direction, and we will consider it as negative. Therefore, we need to subtract the moment of force P2 in this equation. Okay, and the moment of force P2 is P2 into OB dash. OB dash is the perpendicular distance between the point O and the line of action of force P2. Simplifying, we can say that P1 and P2 are equal to P. Okay, since these forces constitute a couple and the forces are equal in magnitude, let us say that the magnitude of this force is P. And from the figure, we know that OA dash is equal to OB dash plus A. Okay, so we can write that moment of the couple is equal to P into OB dash plus A minus P into OB dash. Simplifying, we will get P into A. Now this equation does not have any parameters that tell us that there is a point. Okay, if there is a point, we have coordinates, right? But the equation of moment of couple does not include any parameters that connect it to a point. Okay, which means that the couple has the same moment about every point in space. If we change this point also, we will get the moment of couple as same. This will be equal to P into A. A is the arm of the couple, or the distance, or the perpendicular distance between the lines of action of the forces. Okay, therefore the correct answer is option B. Moment of a couple about any point in space is always same, or the couple has the same moment about every point in space. For this reason, the moment of a couple is a free vector, which means that we can move a couple anywhere in space and the effect of this couple will be same. Now the next question is, which of the following statement is correct? Option A, the algebraic sum of the forces constituting the couple is 0. Option B, the algebraic sum of the moments of the forces constituting the couple about any point is the same. Option C, a couple cannot be balanced by a single force but can only be balanced by a couple of opposite direction. Option D, all of the above. We have already seen that a couple constitutes of two forces having equal magnitude and acting opposite to each other. So the algebraic sum of the forces constituting couple is 0. Similarly, we have seen that the moment of the force, moment of the couple, or the algebraic sum of the moment of the force constituting the couple about any point is the same. Okay. Now the resultant force, or the algebraic sum of the forces of couple is 0. Therefore, this couple cannot be replaced or balanced by a single force. Okay, it can only be balanced by a couple of opposite sends. And also, any number of coplanar couples can be reduced to a single couple. If there are number of coplanar couples, it can be reduced to a single couple, and the magnitude of this single couple will be the sum of the moments of all the couples. Okay, so the correct answer is option D. Which of the following statements is correct? The algebraic sum of the forces constituting the couple is 0, which is true. The algebraic sum of the moments of the forces constituting the couple about any point is the same. This statement is also true. And a couple cannot be balanced by a single force but can only be balanced by a couple of opposite sends. This is also correct. Okay, that's all in this video. Thank you.